Okay, the last part of the inverse section is going to be about inverse trig functions. So the three main trig functions that we worked with were sine, cosine, and tangent. So we're going to look at the inverse of all three of those. So let's first start with sine. What was the graph of the sine function? Well, the sine function went through the origin, and then it kind of repeated, going back and forth between 1 and -1 in both directions. So this was sine of x. Does an inverse to this function exist? Definitely not. We can draw a lot of horizontal lines that intersect this graph infinitely many times, so what we have to do is restrict the domain. So the way we're going to restrict it is to only look at this little piece of it. So that little piece is just the piece from -pi/2 to pi/2. So we're going to restrict the domain to be -pi/2 to pi/2. By doing that, now sine inverse does exist. So the way sine inverse is written is sine to the -1 of x. For sine, remember I put in an angle and I gave you a number out. For the sine inverse, I'm going to give you the number, you give me the corresponding angle. So sine inverse of x equals theta is the inverse to sine of x. What this means is that sine of theta had to equal x. So again, we had to restrict the domain, so the only outputs we can get are from -pi/2 to pi/2. So anything else we're not going to be able to get. So what we're going to do for this is look at our unit circle. Get out your unit circle and let's see what we can get. By restricting the domain of f from -pi/2 to pi/2, sine inverse is only looking at the right-hand side of the unit circle. So this is -pi/2 to pi/2. This is the only side of the unit circle we look for sine inverse. So let's do a few examples with that. So sine inverse of 1/2. So sine inverse of 1/2 is saying on the right-hand side of my unit circle, when is sine equal to 1/2? Remember, sine is my y-coordinate, so look at the y-coordinates on the right-hand side. Do I have any of them equaling 1/2? Yes, right here. What was the angle at that point? Pi/6. So sine inverse of 1/2 is pi/6, and this is because sine of pi/6 is 1/2. And remember, we're only looking at the right-hand side of the unit circle. So I agree there is another point over here where the y-coordinate was 1/2, but that's on the left-hand side. We had to restrict the domain. So we're only looking at the right-hand side of the unit circle. Let's do one more. How about sine inverse of -2/2? So I'm saying what angle gives me that sine is -2/2. So let's look back at our unit circle. For sine, we look at the right-hand side, so all of these. Where is my y-coordinate? -2/2. So look through here, it would be here. What angle is that? That's 7pi/4, but remember we're only doing negatives, to pi/2 to positive pi/2. So this is actually -pi/4. So -pi/4. We don't measure it this way when we talk about the inverse. We don't go counterclockwise. We do -pi/2 to pi/2. So this is -pi/4. And again, this is because sine of -pi/4 is -2/2. So that's sine inverse. Sine inverse, you always look to the right-hand side of the unit circle and ask yourself, what angle is giving me where the y-coordinate is this inside value? Second one we're going to look at is cosine. So let's first recall, what does cosine actually look like? Cosine went through 0, 1, and repeated like that. Bounced back and forth between -1 and 1. Well, is this invertible as it is? Definitely not. You can see that there are tons of horizontal lines I could draw, so I'm going to restrict it to just look at that little piece there. this piece, or this point, corresponded to where I got pi. So I'm only going to look at the domain between 0 and pi. So I'm going to restrict the domain to be 0 to pi. What does that mean as far as my unit circle goes? So for the sine, I restricted it to negative pi over 2 to pi over 2, which was the right-hand side. Now I'm restricting cosine to 0 to pi, so this is the top half of the circle. So sine inverse, you look at the right half. Cosine inverse, we're going to look at the top half. It's important to note here, what is the range? We didn't say this for sine because it's going to be the same thing, but what is the range? So go back to our cosine graph. I'm only looking between these 2 points. What's the range? So what's the smallest y value and what's the largest y value? So the smallest was -1, largest was 1, so that's going to be my range. And this is true for sine inverse also. Okay, so what's my inverse? Cosine inverse of x. That's the inverse of cosine. Inverse of cosine of x. Should say cosine of theta equals x. So for cosine, I gave you an angle, you gave me the x-coordinate. Now I'm giving you the x-coordinate, you tell me what was the corresponding angle, keeping in mind that we're only looking at the top half of the unit circle. So that's what cosine inverse is. So let's do some examples. What is cosine inverse of -1/2? So remember, for cosine inverse, we only look at the top half of the unit circle. So I'm only looking up here. Cosine is talking about the x-coordinate. So I'm saying, where is my x-coordinate -1/2? So let's look at the top half of the circle. You can see the x-coordinate's -1/2 here. What's my angle measure? That would be 2 pi over 3. So the inverse is always giving me an angle. So this is because cosine of 2 pi over 3 was equal to -1/2. And how about cosine inverse of square root of 3 over 2? So cosine inverse, we're talking about the top half of the circle. So in the top half of the circle, where do I have an x-coordinate that is square root of 3 over 2? So if we look at our x-coordinates, you can see it's here. What's my angle measure there? Pi over 6. So this is because cosine of pi over 6 equals the square root of 3 over 2. Okay, so that's cosine and sine. Lastly, let's talk about tangent. What does the graph of tangent look like? Tangent was the one that had all of those vertical asymptotes. It had them at pi over 2, had them at negative pi over 2, and it kept going. So it had a bunch of vertical asymptotes. And then I had the line going through, the curve going through the origin, and it just kind of repeated itself infinitely many times. Is this graph invertible as I have it written? Definitely not. Again, any horizontal line I draw is going to intersect it tons of times, so I'm going to just get rid of all of this. I'm only going to look at this small chunk here. By doing that, what's my restricted domain going to be? Negative pi over 2 to pi over 2. But the range is different this time. So the range for sine and cosine, that only went from -1 to 1. Because that's what the curve did. But now, what is the range of this function? Well, it goes down forever and up forever, so the range is all real numbers. For the inverse of tangent, we're going to do just what we've been doing. So tan inverse of x equals theta is the inverse of tan of theta equals x. So just like before, the inverse, I give you a number, you tell me what angle corresponded to that number. One thing that we do want to recall is that tangent of a number, so tangent of theta, is sine theta over cosine theta. So this is taking the y-coordinate and dividing it by the x-coordinate on our unit circle. So we do want to recall that when we're talking about tangent. So let's go through a couple here. tan inverse of 1. Also, for tangent, we do the same thing that we did for inverse sine. We're only going to look at the right-hand side because we restricted our domain. Remember, the restriction was negative pi over 2 to pi over 2, so we're looking at the right-hand side. We want the tangent to be 1, so we're looking for tan inverse of 1. Remember, this is the y-coordinate over the x-coordinate. Well, if the y-coordinate over the x-coordinate is 1, that means they have to be the same. So where on the right-hand side do I have that the x and y-coordinate are the same? So that would be here. Whenever I divide these two, I'm going to get 1. So this is pi over 4. And that's because tangent of pi over 4 is 1. Okay, and then lastly, let's look at tangent inverse of negative 1 over square root of 3. So for tangent inverse, we look at the right-hand side. So I'm looking here. I want the y-coordinate divided by the x-coordinate to be negative 1 over the square root of 3. So can we see anywhere where if I divide the y-coordinate by the x-coordinate, I get the square root of 3? Well, how about this point here? What happens if I divide negative 1/2 by the square root of 3 over 2? I get negative 1 over the square root of 3. What's that angle there? That's 11 pi over 6, but remember, we don't put 11 pi over 6. We measure this from pi over 2 and then negative pi over 2. So this is negative pi over 6. And this is because tangent of negative pi over 6 is negative 1 over the square root of 3. So for our three inverse functions, we have that sine inverse only look at the right-hand side, where it's measuring from negative pi over 2 to pi over 2. So all of these down here you represent as negative angles, not what's written. Cosine inverse, look at the top half. Tangent inverse, look at the right half. For the inverse, you ask yourself, which coordinate gives me the desired angle? And the angle is going to be your answer. So keep that in mind when you're doing the inverse functions of trigonometric functions.